sickle shape. And as you can see, it's very dangerous in terms of flowing in the blood vessel. And the next example is to understand mechanism of drug resistance. So this example is the Plasmodium falciparum chloroquine resistant transporter. And chloroquine for a very long time was used to treat malaria, but recently you don't hear about chloroquine because the parasite have developed resistance for this drug. And they solved the structure of this protein and realized they mapped out the mutations that have occurred that is causing this resistance. And this can be exploited further in terms of generating new, in terms of optimizing the chloroquine molecule to restore its efficacy. So the next example is quite similar. It's a AfLS protein located on the outer membrane of bacteria. So what happens when antibiotic gets in, they pump it out, and this helps it to develop resistance. With structural biology, you can understand this process and know how and possibly find a way to block these AfLS proteins to restore the efficacy of these antibiotics. The next example is MSP1, which is a vaccine candidate for antigen for vaccine discovery. So for several years, they've been working on this protein. The structure was unknown, and recently in 2021, the structure was solved, and this can be exploited further for identification of antigen epitope mapping and for rational design of the vaccine. The next example is in COVID-19. So basically from 2019 to 2020, the take-home message is that within 1 year, more than 1,000 structures were deposited in the PDB. And these are some of the structures for the virus. As you can see here, RNA-dependent RNA polymerase. Then you have the glucocorticoid receptor in complex with dexamethasone. And this dexamethasone was shown to offer some release to critically ill COVID-19 patients. So the next example is also one of my research. So most viruses such as HIV and influenza, they rely on sialic acid on the surface of glycoproteins to be able to attach to the cell and release the viral content. So how is the sialic acid decorated on the surface of this glycoprotein was unknown. So my research helped to solve the structure of this protein, the CMP sialic acid transporter, which transports CMP sialic acid from the cytosol into the Golgi for glycosylation to take place, for the sugar molecule to be added to the glycoprotein. So we solved the structure by lipidic cubic phase to 2.8 angstrom. And we identified the residues that are coordinating the nucleotide sugar and did some mutation to validate the binding pocket. The next example is to understand how you can utilize structures to enhance existing medicine. For instance, this is the Mycobacterium RNA polymerase. The drug that they were using to treat TB was this rifampin. As you can see here in red, it binds somewhat outside the catalytic pocket, as you can see the black circle. But using structural biology, they discovered another